So next continuation of Euclid's lemma. Please see here, children. So we have to prove that square of any positive integer, is in the form of 4q and 4q plus 1. 4q and 4q plus 1. Please see, children. So as it is 4, b is 4. As bq plus r and b is 4, remainder lies between 0 and b. Remainder lies between 0 and 4. What are the possible conditions? 4q plus 1, 4q plus 2, 4q plus 3. All we have to do squaring, children. If you do squaring of 4q square, please see here, children. 4 you take common, 4q square, and this we will write it as q only because they asked for q only. So this is 4q. Again, do the squaring, children. 4q plus 1 whole square. If you do 4q plus 1 whole square, a square 2ab plus b square. Take till here 4 common, children. What do you get? 4q square plus 2q plus 1. This again will write as q only, 4q plus 1. Go for 4q plus 2 whole square, children. If you do 4q plus 2 whole square, a square 2ab plus b square. B square is 2 square. 2 square means 4. 4 will go in 4. So children, practice along with me. It will be also easy for tomorrow exam. Okay, 4q square plus 2 2s are 4q is left over plus 1. What is this? In the form of 4q. First one was 4q, second was 4q plus 1, third one is 4q. And let's see what is the next one. 4q plus 3. 4q plus 3 whole square. When you do 4q plus 3 whole square, a square plus 2ab plus b square. B square means 3 square. 3 square means 9. 9 means 8 plus 1 I will write, children. 9 means 8 plus 1 I will write. So 4 I will take common. 4q square plus 2 3s are 6 6q. Because 1 4 is outside, no, children. Plus 2 plus 1. This I will write as 4q plus 1. So all are in what terms, children? Either 4q plus 1, 4q plus 1. That's what he asked. No? He also asked that only. Like this we have to do, children. Okay. Next one. What is the next question, children? To prove that square of any positive integer is in the form of 5q plus 1. Already 10th sum I did, children. Same sum. Go for the 12th question, children. 12. Prove that square of any positive integer in the form of 8q plus 1. Prove that square of any positive integer is in the form of 8q plus 1, children. Since 8q plus 1 is very big number, normally what we will do, children? 8q plus 1. 8q plus 1 means bq plus r. In b place, who is there, children? 8. So remainder lies between 0 and b. Remainder lies between 0 and 8. So 8q plus 1, 8q plus 2, 8q plus 3, up to 8q plus 7. Okay, children, up to 8q plus 7. But since 8 is very big number, if you show with 4 also, it is enough, children. Now only I showed you 4, no, children. 4q plus 1 you are getting, no. Either you are getting 4q or 4q plus 1. Now only I showed, no. Like that you just show with 4. If it is divisible by 4, it is also divisible by 8. Like that you show, it is enough, children. Okay, because for 6 we will take 3, for 8 we can take 4. No, sir, I want to do with everyone means do for only odd numbers, children, because there I missed in the question odd number. You have to show for odd numbers only. You'll get everything in the form of 8q plus 1 only, children. Okay, so show for odd numbers only, children, not for all numbers. If you want 2 numbers, I will show here. For this number square, I will show. See here, 8q plus 1 whole square, a square, 2ab plus b square. Till here 8 is divided by 8. 8q square plus 2q plus 1. Here what is that? 8q plus 1. Only for odd numbers you have to show, children. Only for odd numbers. Okay, 8q plus 3 whole square, children, a square 2ab plus b square. B square means 9. 9 means 8 plus 1, children. Till here 8 you take common. What is left over, children? 8q square plus 6q plus 1 plus 1. This is what? 8q plus 1. Like this you have to show for all odd numbers. You'll get 8q plus 1 only. Same procedure again. Waste of time. You have to do, children. Okay, you practice. This is only revision class I am doing. I am helping for your tomorrow's exam, children. Don't panic. They are very easy, some children. How much you practice, that much you'll become perfect. Don't simply keep on saying that they are very tough sums. Okay, 13th one. Prove that n square minus 1. Prove that n square minus 1 is divisible by 8 if it is positive. Divisible by 8 means, children, you have to show 8 cube, 8 cube plus 1, 8 cube plus 2, up to 8 cube plus 7. Okay, till 8 cube plus 3, I will show remaining you do, children. Okay, question is show that n square minus 1 is divisible by 8 if n is odd. N is odd means for 1 you should show, for 3 you should show, for 5 you should show, and for 7 you should show. That's all. Not for all numbers. N square minus 1, children, n square minus 1 square, yeah, n plus 1 into n minus 1. Okay, first odd number. This I will show. 8 cube plus 1 plus 1. 8 cube plus 1 minus 1 by 8. Plus 1 minus 1 cancel. 8, 8 cancel. Yes, it is divisible. Next, you have to show with 8 cube plus 3, children. 8 cube plus 3 plus 1 plus 1. 8 cube plus 3 minus 1 by 8. What this will be? 8 cube plus 4. 8 cube plus 2 by 8. Here take 2 common, children. 2 if you take common, 4 cube. Okay, I'm writing up. Okay, here if you take 8 common, 4 common, children, what do you get? 2 cube plus 1. And here also you can take 4 common, 2 cube plus 1. Okay, 8, 4, 8. Here, no, 2 you should take common. No? If you take 2 common, 4 cube plus 1 by 8. 4 2s are 8. Yes. Like that when you show 5 and 7 also, children. If you show 5 and 7 also, it is divisible. That's all. Whatever number is given, how many factors are possible, you should see 8q plus 1, 8q plus 2, up to 8q plus 7. But he's saying odd numbers. So take odd numbers only. See in the question, they have said only odd numbers. Practice, children. This many sums you won't get in your textbook also. I have searched various books and I have given these questions. Okay, n square minus 1. And next, show that 15th question. Prove that every positive integer is in the form of 6q plus 1, 6q plus 3, 6q plus 5. Very easy, no, children. This is 6q plus 1, 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. Up to 5 only, should right? Odd numbers. Here, question is odd numbers. Why? Because 6 up to 5 only. Why I wrote, children? Because remainder lies between 0 and 1. Remainder lies between 0 and 6. Only odd numbers. In the question, I think odd numbers I didn't give, but in exam, compulsory I will give, children. This we have to show. Next one, children. Last 3 sums we'll discuss, children, so that it will be also useful for tomorrow exam. You need not to prepare again separately. Okay, show that square of any positive integer cannot be in the form of 6n plus 1, 6n plus 2, 6n plus 5. Same this numbers only, children. You do all squares. Any square you do, you have to say that it is not coming 6n plus 2 and 6n plus 5. One, 2 sums I will show, children. Remaining you do, children. This one I will show. Square you have to square. If you do square, what do you get, children? A square 2ab plus b square. Till 6 here, if you take common, 6q square plus 2q plus 1. This is in the form of 6q plus 1. Yes, he's saying it won't be in the form of plus 2 and plus 8. That's all, no? Plus 2 and plus 5. Yeah, plus 1 became. Yes, it's not. One more I will show. This I will show you. 6a square 2ab plus b square. B square means 25. 25 means 24 plus 1, children, because 24 goes in 6 table, no? 24 goes in 6 table, you have to take like that. So if you take common, 6q square plus 2 5 is 10q plus 4 plus 1. This I will take 6q plus 1 again and get it. Okay, children, you may get anything, but he's saying you should not get 6m plus 2, 6m plus 5. The question in the link, description link is there. You check that sums. He is saying you should not get 6m plus 2 and 6m plus 5. I mean, he asking, let us take m only, children. Whatever he asks, we'll take that one. Okay. 2 I did, children. Remaining all you try, you'll get it. Okay. So last 2 sums, children. We'll do this 2 sums and then we will stop. Okay. Last 2 sums are that. Please, Nona. You have to practice all types of sums. Next question. Show that one and only one out of n plus 4, n plus 8, n plus 12, n plus 16 is divisible by 5. Is divisible by 5 means 5q, 5q plus 1, 5q plus 2, 5q plus 3, 5q plus 4. Only one among them it is divisible. What is that? N plus 4, n plus 8, n plus 12, n plus 16. Children, This you substitute in this. One among them is divisible by 5. Next, this you substitute. One among them is divisible by 5. Next, substitute this. One among them is divisible by 5. Like that. Okay, children? I'll substitute this both. This 3 you do. Okay? This 2 I will show you. 5 cube plus 3. 5 cube plus 3. Is it divisible by 5? No. 5 cube plus 3 plus 4 by 5. You will get 5 cube plus 7 by 5. Is it divisible by 5? No. Let us check. 5 cube plus 3 plus 8 by 5. That is 5 cube plus 11 by 5. Is it divisible by 5? No. Next you check. 5 cube plus 3 plus 12 by 5. 5 cube plus 15 by 5. 5 you take common, cube plus 3 by 5. 5 cancel. Yes. Next one, no. Like among all this, one only is divisible. I showed with 5 cube plus 3. Anyway, children, 5 cube plus 4 also I will show you for your 5 cube plus 4 by 5. No. Next one, 5 cube plus 4 plus 4. 8 by 5. No. Next one, 5 cube plus 4 plus 8. 5 cube plus 4 plus 8. How much? 5 cube plus 12 by 5. No. Next one, 5 cube plus 4 plus 12 by 5. That is 5 cube plus 16 by 5. No. Next one, 16. 5 cube plus 4 plus 16 by 5. That is 5 cube plus 20 by 5. That is 5 you take common, cube plus 4 by 5. 5, 5. Yes. So all this you substitute. Only among all these things, one is divisible. For 5 cube plus 3, this was divisible. Sorry, this was divisible. This. Which one? Sorry, this one. And for 5 cube plus 4, this was divisible. Like that. Only one among them will be divisible. You have to check for 5 cube. You have to check for 5 cube plus 1. You have to check for 5 cube plus 2. Why? Because he's asking 5. 5 means up to 4 you have to do. That you have to write side. Okay, children, this is standard protocol, children, for doing all these sums. Okay, 18th question, last question. We'll do this and we'll stop this, children. 18th question. Show that square of odd positive integer can be in the form of 6q plus 1, 6q plus 3. Easy, no, children? 6q means 6q, 6q plus 1, 6q plus 2, 6q plus 3. This is textbook question, children. This is first exercise. Odd numbers. This is odd number, this is odd number, this is odd number. Yes, hence proved. That's all. You should not put tick and say. You have to say among these odd numbers are 6q plus 1, 6q plus 3, 6q plus 5. You have to say. Don't put tick and show. I will not give marks. You have to say 6q plus 1, 6q plus 3, 6q plus 5 are odd numbers. Like that you have to say, children. Okay, this is Euclid's lemma. Anyone have any doubts? Means you can ask me now.